A certain bag contains red, blue, and green marbles. What is the ratio of green marbles to the number of red marbles in the bag? So we are looking for our greens over our reds. And they don't tell us anything about our three different colors of marbles. So we got to look at our statements. The number of blue marbles in the bag is 2 times the number of green marbles in the bag. So if we're trying to make, ideally if we can make a ratio for all 3 of our marble colors, that would be great. Here it looks like they give us 2, so we know blue to green. And then we know blue is 2 times green. So if we have 2x, I should say, if we have x green marbles, we should have 2x blue marbles. This tells us absolutely nothing about our red marbles, though, and so we cannot find our green over our red, and this will be insufficient. The number of blue marbles in the bag is 3 times the number of red marbles in the bag. So now we know our blue to our red, and this is a different ratio than our first statement. So I'm not going to use x again here. X is just a multiplier. So we'll say if I have y red marbles in my bag, I should have 3y blue marbles in the bag. Now remember, it's still possible that y is equal to x, so I'm not eliminating necessarily that possibility, but I don't want to necessarily say that my 2 ratios have the same multiplier. So this is the same problem as the first statement. We don't know anything about our green marbles, so that's insufficient. So together, what do we know? So now we have these 2 individual ratios that they gave us. So we have this blue to green of 2x to x, but we also have this ratio of blue to y, blue to red, I should say, of 3y to y. So what I actually want to do here is I want to put blue in the middle, because blue is how everything is connected. So I'm going to write this as green to blue to red. And so green to blue is x to 2x. I'm just flipping these. And then blue to red is 3y to y. And so this is a different ratio. So I'll put that below here like that. Now, what do we know when we put our 2 ratios together? Well, they are connected through blue. And so we know 2x must be equal to 3y, because these are the same set of blue marbles. It's not like I have one set here and one set here. This is the same group of blue marbles. And so based on this, I can get everything in terms of a common multiplier. So let's put everything in terms of x. So y should be equal to 2/3 x. So I want to put everything in terms of x. I can bring this guy down so I can keep him as just x. With my blue marbles, I can choose if I want an x or a y. So we want to choose our x because we're getting everything in terms of x. And then all I have to do is convert my red marbles from y to 2/3 x. And then if I want to get rid of my fraction here, I can just multiply my entire ratio of by 3. So I have a ratio of 3x green marbles to 6x blue marbles to 2x red marbles. And based on this, now that I have the kind of same multiplier for everything, green over red is just going to be 3x over 2x. And those x's cancel out. So 3 over 2. And therefore, C is our answer.